Now that we have ourselves up and running, we're at week 9, okay? We are moving so fast with only 2 weeks left. We're going to continue to work hard, push hard. This week, we have a little bit of a break from mathematics, so to speak, okay, or statistics in the fact of formulas. But before we get to any of that, keep in mind that as we're getting closer, you're going to still want to continue to work on your knowledge checks. If there are any questions on your apply and reflection, please reach out. We do have some previews from last week. Someone reached out, and so I wanted to go over them before we kind of dive into our live session today with chapter 11, talking about presentation of data. Forgive me, I have a cold coming on, so bear with me. We will get through here, okay? But we are taking a break from like working out problems, okay? We'll be talking about data in general and the types of data there is. Now, for those of you that are watching the archive, this is your discussion forum question. Are there any books, movies, or TV shows that you've enjoyed recently that you could recommend? And then why would you recommend them to us? Let's talk about the different books that we enjoy, movies, or even TV shows in the discussion forum. Keeping a little bit light this week. Okay, for our math trivia, what was the number 0 originally called? It was actually a cipher. And pure mathematics is, in its way, the poetry of logical ideas. All right. Now, for our highly missed questions, we're going to start off with a quiz. And what you'll notice is all but one are really just true or false questions, okay? So take heed of these because you may see them again, and I want us to be really prepared for our final exam that's coming up. First question, ensuring that a claim is cleaned before it's sent to an insurance company as part of the ROI process, true or false? That answer is false. Number 2, HIM equipment and supplies are considered labor costs. So we're talking about labor supplies, okay, equipment. That answer is also false. And number 3, the HIM department never generates revenue. True or false? That again is false because they do generate revenue. Okay. Now, this was a repeat on the knowledge check questions as well. You have community physician clinic, a large clinic with 85 providers, experiences 1,500 patient encounters per day. A coding professional is expected to code 150 per day. And then what you're doing is determining the number of coding professionals needed. So for this one, I'm going to give you the answer, 9, 10, 12, and 11, but I want you to go back and look at the FTEs to actually formulate this particular answer. So you're looking at trying to determine the amount of FTEs that you need. So you know the answer is 10. What you'll also notice is that they're expected to code 150 records per day. Now keep in mind, there's going to be information that is not necessarily relevant to our actual answer. We're trying to determine how many FTEs. So it is cool that there's a large clinic that has 85 providers, but that is just added information, okay? What you're looking at is how many records the coders are expected to complete per day and how many patient encounters there are per day. And you're going to divide, right, records per day by the amount of patients. And that's going to give you the correct answer, which is 10. All right. And that was it for the quiz. All right. So true, false, and then, of course, this math problem. Now for our knowledge check. Okay. Whether a coder is coding outpatient overnight stays or inpatient lengthy is a factor in the productivity standard for the coder. That is true or false. And this particular answer is true. And the last question, most supervisors are responsible for budgeting. True or false? That again is true. All right. So if you are looking to move up and go into a managerial position, just keep in mind that you are going to be looking at budgeting. And with that, you're looking at FTEs, you're looking at how many part-time employees, full-time employees, their work hours, all that goes into it, as well as the fiscal year, operational budget, capital budget, the whole gamut goes into supervisors' responsibilities. That is it for the highly missed questions. Honestly, good job. Just a really quick friendly reminder that due to the observation of Labor Day, class will be at 1800 or 6 p.m. next week, as opposed to our normally scheduled time of 5 p.m. Okay. So for everyone who can attend week 10, just keep in mind, we are going 1 hour later. Okay. Just 1 hour later. And it will be at 6 p.m. as opposed to 5 p.m. Pacific Standard Time. And then I wanted to just recap, like I mentioned, I did receive a question on these two particular problems that were on the apply and reflection. This is from last week. So I kind of wanted to go over them with you guys because you never know, somebody else may have had the same question. So we had this particular problem. A community hospital. Each full-time employee is required to work 2,080 hours annually. The table that follows shows the amount of time that 5 employees were absent from work over the past year. What you're doing is answering the questions below, assuming that all employees work 2,080 hours using leading zeros and rounding to 2 decimal places. Okay, again, this is from last week. And anyone who ever has a problem that you're like, I've been working it, y'all let me know so that we can kind of go over it usually the next session. Okay, I'll try to make sure that I send you like an individual, like, hey, this is what we're looking at, and then come like follow back up so that the class kind of, you never know, somebody else may have the same question. So the two questions that I was asked about was, what is the sick leave rate for employee A? So here, this is employee A, and we're talking about just their sick leave. Okay, so when we're talking about sick leave hours, we're only concentrating here. What you would do here is take the sick leave hours divided by the 2,080 hours annually, and that's going to give you the sick rate for employee A. Okay, so 6 divided by 2,080 hours. All right, that gives you that particular answer. For the second question that was brought to me, it was, what is the total absentee rate for employee B? Now for this one, we want to know anytime they were gone from work. So this includes vacation as well as your sick leave hours. And you're really looking at like the percentage, right? You're trying to find out what is the percentage that this particular person was absent from work. So for this one, you take your 22 plus your 16, okay? 22 plus the 16, you add that together, then you divide that by 2,080. That's going to give you a decimal, but we want that percent. So you're going to multiply that answer by 100. Looking at 2 decimal places, okay? So that's how you're going to determine what the actual amount of percentage this this person, this employee was absent from work, okay? Again, just recapping, 22 plus 16, get that, divide the sum of these two by 2080, multiply by 100, look at 2 decimal places. All right, so that was just a recap from the 2 questions that I was presented. Now we're going to get into chapter 11. And here, honestly, we're just looking at presentation of data. We've done all of our statistics, right? We've figured out our FTEs. We looked at different rates, determining everything from a particular doctor and the mortality rate to what we need for our operational and capital budget. Now we need to present it. We need to put it in a way where what we have written down, what we've calculated, can be understood by our stakeholders, by our directors, by our managers, by our end users, and even staff. With that, we are going to be explaining, differentiating, and applying nominal, ordinal, interval, ratio. We're just going to talk about the different terms when we are describing the data. We're going to distinguish between tables and following different graphs, bar, pie charts, line graphs, histograms, polygons, even pictograms, just to name a few. We're going to talk about creating tables and graphs to really just display all of this hard work that we've been doing over the last 9 weeks or 8 weeks, right? And the last part of the chapter is just talking about preparing the basic elements of a report. You worked hard. You want to make sure that people understand the importance of everything that you've been going through and all the work that you've been doing. So we start off talking about descriptive statistics. The most common type of statistics that the health information technician will encounter. This is what we're going to be encountering day in and day out, or what you're responsible for. You're looking at describing populations of patients, medical services, nursing units, hospital departments, all of those calculations that we've been doing, okay? You're also providing an overview of the general features of a set of data. It can assume a lot of different types of forms, meaning we're going to be bringing in tables, we're going to be bringing in graphs, and we're going to have these as descriptions of the information that we have calculated, okay? We look at categorical data right off the bat. Now, this is going to be data that's collected and sorted into different groups, okay? 2 major groups that you see, nominal and ordinal. A nominal data is going to be the lowest level of measurement. The word nominal just means pertaining to a different name. So you see movie genres, hair color, religion, all right? Other examples could be true or false, male or female. It could even have different types of insurance carriers or patient occupations. Ordinal data. Now, here we're putting our data with values, and they're going to be in order categories. The word ordinal means putting something in order, right? Ordinal, putting in order. So you have an ordinal scale. Only the order of the numbers is meaningful, not the value of the numbers themselves. So you're kind of seeing movie ratings on a scale of 1 to 10. How would you rate a movie like Sharknado? Or, we have the pain scale on a scale of 0 to 10, 0 being no pain, 10 being the most pain that you've ever experienced in your life. How would you rate it? All right. Now, numerical data refers to the data that is in the form of numbers and not in any language or descriptive form. It's often referred to as quantitative data. Numerical data is going to be collected in number form and stands different from any form of number data types due to its ability to be statistically and arithmetically calculated. Okay, types of quantitative data. You have counters, people come into the club, they're counting to see how many people are coming in, your height, your measurements, you're saying, on your driver's license, let's say you put 5'8", but you're really just 5'7 3/4, right? And so on. Another type that the chapter talks about is interval data. Now, this is the type of data that just represents observations that can be measured on an evenly distributed scale, beginning at the point of 0. And I grabbed the example from the chapter where we're looking at temperature being an interval data. The difference between 7 degrees and 71 degrees Fahrenheit is the equivalent to the difference between 75 and 76, meaning there's only 1 degree difference between the two. Temperature has no 0 point. The temperature cold could be 0 degrees, but that does not mean that there's no temperature, right? Only that it is really cold, okay? Because then you start going into the negative numbers. The difference between interval and ratio data is actually really simple. Ratio data does have a defined 0. Income, you can make no money, you can make a bunch of money. Height, when you could start off at 0 when you're in the womb, and then all of a sudden you're 6'20". That's not really 6'10", okay? Weight, we all like to be a little bit smaller. Annual sales, market shares, product defect, time to repurchase, just to name a few. Now, the difference between 2 consecutive years would be the same. The difference between the age 1 and 3 is 2 years. The difference between the age 55 and 57 is also 2 years. And so you can kind of get where that's going. There is a 0 point in that the 0 mean an absent of age or birth. Someone who is 100 years old is twice as old as someone who is 50 years old, okay? Chapter also talks about discrete data. Typically, we're looking at whole numbers. They can have only finite number of specified values. The number of children in a family is an example of discrete data. A family can have 2 or 3 children. They can have 2.5 or 3.5. The numbers represent actual measurable quantities or counts rather than a different label or a category. So other examples we can look at: the number of motor vehicle accidents in a particular community, the number of times a woman has given birth, the number of new cases of cancer in a particular state within a particular amount of years, and even the number of beds available in your hospital, right? These are just other examples of discrete data. The chapter also talks about natural order. The difference between 1 and 2 births is the same as the difference between 4 and 5. The number of birth is going to be restricted to whole numbers. A woman cannot give birth 2.3 times, okay? We also talk about continuous data in this chapter. Now, continuous data represents measurable quantities, but they're not restricted to certain specific values, okay? A variable that is continuous can take on fractional values, so keep that in mind. For example, patient comes in complaining of blurred vision, warm to touch, their temperature's taken and they have 100.2 degrees temperature, right? That can happen. Another example, we look at height. One could say that someone is approximately 6 foot tall. We refine that to 5'10", and then we can refine that even further to 5'10 and a half. Age is yet another example of continuous data. A person may have been 20 years old on their last birthday, but now the person would be 20 years plus some other part of the year. One of the things the chapter does mention is that the only limiting factor for continuous observation is the degree of accuracy. For example, age can be categorized in different ranges. You often see 0 to 20, 21 to 40, 41 to 50, so on and so on. Measurements on the interval and ratio scales can be grouped. Intervals and ratio variables are continuous, okay? So just keep that in mind. They are continuous. Now, data display is very critical, okay? Because it reveals patterns and behaviors. When preparing statistical reports, we have to make sure that we're defining our objectives and our scope. Questions we're going to be asking ourselves: what information is needed? What information do we want to portray to our audience? What information do we have available? And when we collected the data, was it routine by the facility, or did we have to have additional data along with what we had already collected? So again, I grabbed another table from the chapter, and it just shows variables arranged in columns across the page that identify the individual names, age, clinical service, and the length of stay. And you'll notice that each row just represents one patient. So it's almost like the example that we did when we're looking at our FTEs and their absentee from work, right? Just each row just had one patient: employee A, employee B, employee C, and so on. All right, so we want to display this information. There are a number of advantages to using tables, like more information can be presented. We can get exact values that can be listed to retain precision. We see on here that you have less work, fewer costs are required, and there is flexibility in that is maintained without like distorting the data. And let's be honest, it grabs the attention of the audience because they have something to kind of physically look at versus looking down at a paper and seeing a bunch of numbers, okay? Here are just components, okay? 11.2 is just essential components of what a table is going to have: your title, your stubs, your caption, and your cells. In 11.3, now we're just showing a sample table with the components in it. So here would be like just the template. And then 11.3 is showing what would go in. You have ages, and then you have it broken down to male and females. And as you can see, this is a lung cancer at this particular hospital. We also have to look at frequency. In 11.4, we have the number of patients admitted on each day of the week presented in this particular table. 7 days of the week and just the number of patients. Now, a frequency distribution table, it really helps to look at different classes and categories into which data is grouped, and we have different ranges of each. Now, some things to keep into mind when you're talking about these frequency distribution tables. You do not want to use fewer than 5 or more than 15 categories because you don't want it too big. The audience is going to lose the information because it's going to be like, oh my goodness, this is a lot to kind of take in. You want the categories to be well defined, and categories should mutually be exclusive where each observation is grouped into only one category. That's important. And if at all possible, you want to also make the classes cover equal ranges or different intervals or values because it makes it easier to follow and understand. So the last part of the chapter just breaks down the different display tools, the different graphs and forms that you can put in. And the very first one we look at, we're just talking about graphs. Now, graphs have various types, and they are the best means for presenting data for quick visualizations where you can kind of look at the relationship of what you're trying to present. They often supply a lesser degree of detail than, of course, tables because you're not able to put as much information on them. There are advantages. They grab the audience attention. And the presentation of the data in the form of a graph is an excellent way to just convey the message you really want to get across to your audience. Now, when creating graphs, the chapter does break down specific general guidelines, okay? Your titles, they need to be relatable to what you're displaying in the graph. If you're talking about FTEs, you don't want the information in your graph to talk about your capital budget, unless you are saying that the FTEs are a part of the capital budget, right? You want to make it specific to what you're trying to present to your audience. When several variables are included on the same graph, each should be identified by using a legend or a key, kind of a point of reference, so that your audience can quickly figure out, oh, okay, blue means this, and green means this, or a star means that. Categories should be natural. Your scale captions are going to be placed on the axis to identify the values clearly. Graphs should emphasize the horizontal. It's easier, like straight line, okay? It's easier for the eye to read along the horizontal axis from left to right, because that's how we read, right? Also, graphs should be greater in length than in height, because it's easier to kind of go from this way than kind of looking up. The exact reference to an outside source should also be given. So if you've gotten your information from somewhere else, make sure you're referencing it, okay? We get into bar graphs. Now, bar graphs are also called bar charts. The simplest bar graph is just that one variable graph, okay? You just have one category on the X and Y axis. A grouped bar chart, kind of what you see, is used to display information from tables containing 2 or 3 variables. And you also see that there is a legend, or a key, so you can kind of identify exactly what you're talking about. We come to our pie charts. Think of a pie, have a pizza, split it in half, and you're just dividing the parts. Circle is divided into sections. It's like pie slices or pizza slices. The size of the slice of the pie show the proportion, and it's equal to the whole, or usually 100. So a lot of times with these pies, they're going to be converted into percentages. Pie chart wedges may be shaded or colored to really just help differentiate the sections. Additionally, they can be cut into the pie to help really just emphasize the particular percentages. And again, you see a legend letting you know the percentage or the makeup of each small wedge. Chapter also talks about a line graph, used to show data to just cover time, okay? Days, weeks, months, or even years. The x-axis shows the time period, whereas the y-axis shows the values of the variables. It allows for several variables to kind of just be plotted and then lined to kind of connect the dots. Not to get confused with a histogram. Now, this is a representation of frequency. This is a display frequency distribution because it has a lot of continuous numerical data. Different from bar graphs. Bar graphs display data that fall into categories. I have seen this question before. Histograms illustrate frequency distribution of continuous variables. Histograms are created from frequency tables. Okay. Getting into a frequency polygon. Now, a frequency polygon is a visual representation of distribution. The visualization tool is used to just really understand the shape of distribution. We look at some characteristics. Now, it may be used instead of a histogram, all right? It is similar to a histogram in that it is a graph looking at frequency, but a frequency polygon is in a line form instead of a bar form. So we look at advantages of this one versus a histogram. Several plots can be placed on the same graph to make different comparisons. You use the same axis as a histogram. The x-axis displays the scale of the variable, whereas the y-axis displays the frequency. You also have a dot that's placed at that midpoint. And then these dots, again, are connected by the line that is drawn from one point to the next. This one's one of my favorite ones, to be honest with you. It's pictogram. It's a symbol that conveys meaning through looking at physical objects. It's an attractive alternative type of bar graph that is used really to show pictures, okay? If you want to show the number of individuals, you can draw stick people, all right? It can be very entertaining and it can catch the audience's attention. And then we have our scatter diagram. With this, this is used to really graphically show the relationship between two numerical variables. A scatter diagram is used to determine whether there is some type of relationship between two characteristics. We have correlation implies that there is one variable change, that there's also another one. That does not mean that there's always going to be that cause and effect relationship between two variables, but it does kind of show that they're somewhat related. All right. I have seen questions where they ask about positive and negative. When we talk about a positive scatter diagram, I have seen it again. Okay. So I'll try to make sure I go over it. Positive. Small values of the x-axis correspond to small values of the y-axis. So it's like small and small. Large values of the x-axis correspond with large values of the y-axis. That is positive. Kind of like two smalls are good to go, two larges are good to go. So kind of think of it that way. Now, in the same aspect, when we talk about negative, small and large, they don't match. So small values of the x-axis correspond to large values of the y and vice versa. That is said to be a negative linear relationship. Okay, so positive, small x, small y, large x, large y. Negative, small x, large y, large x, small y. Just in case you see that again somewhere. Now, the last part of this chapter is just preparing reports. All right. Now, writing reports for your workplace is not the same as, going into an article, preparing a paper for your class or for an assignment, but the goal is still the same. Communication is the goal, and it is achieved when you write your report in the style of the way your audience prefers it to. The type of audience is definitely going to determine the type of report you prepare. Healthcare administrators, they usually dictate how reports are prepared and presented, like to your facility, okay? You have a review of previous reports is the best way to kind of figure out how am I going to get my point across and what is expected of me. And you can always get like previous from committees or even your administration, and you just use that as a guide so that you know that you're on the right path and you're kind of staying in tow of what is the norm. But there are general guidelines, okay? Of course, you're going to include a title for the report. If your report is too long, consider placing a list of contents in front of the report to kind of make details easier to locate, i.e., when you have, let's say, your archive and your professor sometimes will break down each section of, okay, this chapter is here, you have a 4-hour online class and you can actually break it down even easier. A lot of YouTube videos, a lot of content creators will have specific content they want to get out to their audience. And so they'll break it down by the minute so that people can easily find the information that they're really trying to get to at that particular point. And that's the same thing you can do with a report. Kind of have tabs and almost like a legend, a written legend to let them know, hey, if you're trying to get to fall risk and what we've done for it, turn to tab 3. Okay. Now, if you're writing a formal report, include, of course, an introduction, just talking about what the purpose of the report is. The body of the report is going to include a narrative, tables, some graphs. They could even be divided with titles. Write the style of your workplace, be objective, report all the pertinent information, both positive and negative. Try to be as bias-free as possible. So you're trying to avoid words like awesome and incredible. And you're going to write in an impersonable style. So you're not going to start your sentence with I compared, but rather a comparison showed. So you're just being neutral and presenting just the facts. You want to be concise and strive for clarity. You're also going to explain any abbreviations and acronyms because you want to assume that people are not going to necessarily know all of the information that you know. You want to try to just break it down to the most layman of terms that you can possibly do without losing the content of what you're trying to present. Of course, you want to proofread your document, improve your grammatical skills, and then you're just going to read your report carefully to just ensure that the graph and tables make sense and are easy to be understood. You may even consider reading the report out loud to see how it sounds. And honestly, this is perfect timing because this is the end of the chapter and we're starting to get lightning. So if for some reason power goes out, I will just upload the rest. Okay, so stick with me if you can. Hopefully everything stays up. All right. Now, for your knowledge checks, I grabbed 2 questions, all right, that you could potentially see. Very first question you see in front of you. Which of the following graphs would be the best for a cancer registrar to use to display the 10-year survival rate of breast cancer patients at your hospital? You have bar graph, histogram, frequency polygon, or a line graph. Okay, so here you're just following patient register and you're looking at a 10-year survival. So here we're looking at a line graph. Okay. Last question. A graph depicting the frequency of continuous data. However, frequency polygon is a line form of a bar form. Discrete, interval, frequency polygram, or histogram. Here, the answer is in the question, a frequency polygon. So we're gonna have to look at that question just in case you guys get it. And this brings us to the end of week 9's live session. For those of you who are watching the playback, are there any books, movies, or TV shows that you've enjoyed recently that you would recommend? And then why would you recommend them? Let's talk about that in the discussion forum. Chapter 11 was just about presentation of data, looking at the different data types, what each different data display tool would be best used for, and a very brief kind of intro into preparing reports, because many of you will be preparing these reports and providing this information to your future facilities. We went over a couple of poll/knowledge chat questions, and this is the wrap up. For those of you who are really comfortable with this week's apply and reflection, this is where I bid you adieu, and I look forward to seeing you next week at 6 p.m. Pacific Standard Time for week 10's live session. Don't worry, I'm still going to put out an announcement just to kind of remind you guys that, hey, we meet at 6 instead of 5, okay? And for those of you who kind of just want to make sure that you have a good understanding on this week's apply and reflection, we're getting ready to get into it right now. All right. So the very first part They're just multiple choice questions, and it's all going to be based on tonight's live session, all right? 9 multiple choice questions, asking different things about graphs, display tools, etc. Okay, but for exercise 2, you have data, okay, that you're going to be using, and you're going to create an Excel spreadsheet. The very first question is creating a bar graph that shows the live discharges and deaths for each service listed. Okay, so you're just creating a bar graph with this information. Make sure you have the services provided as well as this information, because it's going to be extremely important as you create your bar graph. The second question is, now you're creating a pie chart with discharge days for each service. So for the first one, you have 3 parts: services, live discharges, and deaths that have to be bar graphed. For the second one, for full credit, you have to have both bar graph and a pie chart. Your pie chart is going to have 2 variables, the services as well as your discharge days only. So you have a couple of ways that you can submit this information. You can, of course, do the Excel sheet and submit it. You can also do screenshots as well after you've done it. Some of you may be more comfortable doing Excel from, just your regular computer, taking screenshots of that and then uploading it. And some of you may feel really comfortable using the Google Excel and sending me the link. Keep in mind, if you send me the link and I'm not able to get it at first, I'll send you a message just saying, hey, can I get permission? It's funny like that. Sometimes it does for some students and doesn't for others, but I will send you a message just saying, hey, may I please get permission to view it? I'll take a screenshot and upload it on my end so that everyone else can, like who does our auditing and stuff will see, no, they did do it and this is what they did. Okay, so just make sure that for this one, I do need to have the 2, a bar graph with 3 elements, a bar chart with 2 elements. Okay, and then just submit those as normal. This brings us back to the end. Cannot believe we're already at week 9. Week 10 is next week. Again, just a quick reminder, we meet at 6 p.m. Pacific Standard Time as opposed to 5. Your surveys come out next week, so be on the lookout of me sending reminders just to kind of, hey, get on it a little bit when you can. And we will be just finalizing everything, making sure you guys are really good and prepared for your final exam, which is only 2 weeks away. If you do have any questions or concerns, y'all, please just let me know so that I can go ahead and get that prepared and have it ready so that any questions that come up, it doesn't matter if it's from week 1 to week 10, we can cover that on week 11 before you guys take your exam. I may even be able to prepare something and kind of have it in your announcement so you can kind of go over it and just have it as another resource. So any questions you have, y'all, please, please, please reach out. What questions do you have for me? No questions? Awesome. All right. Well, thank you guys so much for being here. Keep it up. 2 weeks left. We're almost there. You guys have a wonderful rest of your evening. For those of you who are with me in the East Coast, especially in Florida, y'all be safe. Hopefully it's starting to cool down as we start getting into the kind of fall, because it's been super hot during the summer, I must say. But you guys have a wonderful weekend, and I will see everyone who can attend next week's live session. You guys have a good night. Yes, be safe, everyone. Good night.